So again, the classification of materials in terms of resistivity. So the conductor is having the least resistivity: silver, gold, copper, steel, seawater. All those are nothing but your conductors, we can say. Insulator, rubber, glass, oil, diamond, that dry wood, all this considers as insulator. Semiconductor, germanium, silicons, yeah. So then transistors, which are made from all those your semiconductors. So all this comes under your semiconductor. So what are the common commercial resistors which are available, which are wire bound resistors, which were used initially, but these days obviously the resistors are made from carbons, yeah. So that is nothing but we will call them as a carbon resistors. So how these carbon resistors exactly, you can say how it has been just manufactured, and this is how to identify. So how to identify that your particular value for your resistor for this particular case, yeah. So this is how the resistor looks like. So it is having the different rings. Total there are 4 rings. The first band, I will say that it is called as a first significant digits, then there is a second significant digits, then again the third significant digits, and the fourth one is called as a tolerance. So it's not like that whatever resistors we manufactured, it will give you the correct value. So there is some tolerance. Let's say if I'm consider that I designed the resistance for your 100 ohm, yeah, but definitely it might be up to 110 or 90. If the tolerance is less, then obviously its accuracy is more, yeah, and if its tolerance is greater, then it's less accurate. So this is how we will just define the color code for your carbon resistors. Actually again you have to just identify the values has been defined for each one of them. So there is one sequence. So this is actually the sequence which I just write it down. For example, for the few things, yeah. So this is your black, then this is your brown, red, then orange, yeah. So then this is your yellow, yeah. So this is BB, you can say this is Roy, BB Roy of Great Britain, yeah. So this is great, again this is Britain having that gorgeous, then that W, yeah. So this is how we can just write it down, that sequence, yeah. So that again this is green, this is blue, yeah, and then again I will say that this is your gray, yeah, and then finally so that is your white. So this is how we can just write it down, that color code for your carbon resistor. So for this case, yeah, so for this case obviously we just define some significant digits 0 1 2 3 4 5 6 7 8 9, yeah. So likewise you have to just define the significant digits for this color code. So this is how we will just define. So once again I will just repeat that pattern. So BB Roy of Great, yeah, so that of Great Britain having your gorgeous wife. So this is also how you can remember it. So this is green, then this is your blue, then violet, yeah, again this is your gray, and then finally it is white up to the 9. Okay, so fine. So this is how you can just remember this sequence, and obviously there is one multiplier. So this is 10 raised to 0, yeah. So this is what we will call as a multiplier over here, okay, and this is the significant digit which is associated with that. So 10 raised to 2, 10 raised to 3, 10 raised to 4, 5 6 7 8 9, yeah. And at the same time there is some tolerance also, yeah. So there is some tolerance also. So I just told you how to remember that your color code, yeah. So just to remember that color code, we have just, I told you that. So this is the sequence. So this is your BB, then you can say that BB Roy of Great Britain having your gorgeous wife, yeah. So this is how we can remember that sequence over here. So this is the technique to remember that code also. So let's say for example now, so the color code of the 4 bands, so it is given over here, find the resistance. So I just show that. So let's say this is the resistor, obviously then which is known that, so there are 4 rings. So this is how I can show, let's say these rings, yeah. So this is 2, first significant digit, you have to write it down as it is, then second one also write down as it is, for the third one write down its multiplier, yeah, and then again add its tolerance, that is a plus or minus 10%. Okay, so then definitely I can say this is 2200, so which I will call as a 2.2 kilo ohm with a error of 10%. So this is how we'll get the value for this your resistance in this particular case.